So what we would have is that I would have fallen from 1 to e to the minus. Okay, so I have e. The real part is minus 0.453 t times sine of something sine of 0.126 t plus something cosine 0.126.
What is that something?
T. Something is the pre-exponential coefficient. We don't calculate any pre-exponential coefficients at all. So, after time 25, how much is going to be the amplitude? It's going to be e to the minus 0.453 times 25, which is about e to the minus 10. That's really time. You see that? So that's about e to the minus 10, not observed. Okay? The amplitude at the half period is going to be e to the minus 10. So when you do the very last problem and plot what the actual response is, you should not see the oscillation. You will see exactly what I mean. Mathematically it's there, but you should not see it. So anyway, that's all you need to say. This is just explanation. You don't have to put that in the hole. That this is bigger than this means you are not noticing. Clear? So we have oscillations, but they are not observable. What is number 4? Inverse response, right? Well, I'll roll up to that. We have Z1 is a positive number, 1.3, positive, so yes. So that means that our qualitative plot starts at 24.24, ends up at 24.37. But since we have inverse response, what's the very first thing that happens? It goes down. But actually, before I draw the picture, let's do number 5, corner. How many poles do I have? So number of poles. How many zeros do I have? So the pole excess minus 1. So the pole excess is 1. Okay? So, corner. And when will the corner happen?
Beginning.
At time t naught plus d. What's the delay? So the change happened at time 0. What's my delay? Let's look at the transfer function. 1. So at t equals t naught plus d. So at time 1, so it stays at 24, 24 until time 1, and at time So first I will dip down, and then I will go up. And I will go up with oscillations that I don't see. What was number 6? Approximate cancellation. I don't have approximate cancellation. And cancellation of the exact pole. If I have the real part the same, that doesn't cancel. It's the entire pole must be cancelled by a 0. Okay, so if I had a 0 with exactly the same real part as the poles, it doesn't cancel each other. Okay, guys? So 6 doesn't do anything, so we're ready to try it. So it's going to be an inverse response, and it will come up, but we won't be able to see the oscillations. It will look like that, even though mathematically we have oscillations. Does it come together now, guys, with this example? Dylan?
So there is discontinuity, right?
Yeah, there is a corner at 1. Yes, at 1 there's a corner. You will see, when you plot the quantitative answer, you'll see that there's a corner. So that completely answers problem. So let's cover your homework. So, find poles and zeros. Done that, I hope. Okay, poles and zeros, drop a briefly explain your reasoning. I did the explaining all along. And then, estimate the time required for the process to reach a new steady state. So I guess the picture is the last part. So just the answer would be the part of E. No, wait a minute. No, I did that. Okay, yeah. Okay, let's do it. So that's the end of it. And what is H?
You again for you instead of the service.
Oh, that's the difference. Okay, so the other one. Okay, that I will let you get. The poles are the same, but in this case, you probably will not have a right-hand side 0. You may not even have a 0 at all. Right? Does the GFC have a 0? Is the numerator just a constant, or does it have an S?
No,
it's got an S.
But the root must be negative. The root must be negative.
Yeah.
It's negative 0.5.
Yeah. So that doesn't have inverse response. So when you do GFC, it won't have inverse response. So same thing for G. Now I'm asking you the last part. Estimate the request to reach a new steady state. And that's for the change that was part of G. John, that means part of G if it wasn't clear. So for this one, I'm not actually using this state for the GFC. For this one. Okay, estimate time to reach new steady state. Now in this case, because I have inverse response, it will be a bit higher than what I missed. Okay? But what is tau dominant? Is -1 over the real part of P dominant. In other words, -1 over what's the real part of P dominant? Minus 0.453. So over minus. So that's about 2. Someone with a calculator tell me. 2 point. Let's say 2.2. So this steady state is going to be equal to 0 for T naught, 1 for the delay, plus 4 times 2.2, which is about 9, 8.8. So you should say in your graph, in the very last, I hope. How did I ask the last problem? Oh. Done it for GFC. I should have done it for GF. Well, you already did it, and I'm not going to ask you to redo it.
No.
I want you to study, I don't want you to. So,
For how does exactly I work? How is that different?
it's different input that changed.
But this one asks by inverting Laplace transforms.
Yes.
Instead of just doing the picture.
Yeah, so this, you need to do the whole thing. That was, I told you, this is a lot of work. I is a lot of work. You have to first find the Laplace transform of FC deviation, calculate y prime bar, which is GFC times FC prime bar, partial fractions expansion, inverse, put it together, and plot the equation that you got.
But then the equation I have is, it's a combined constant.
Oh!
What do I do?
Oh, I didn't cover that. I forgot that's complex conjugate. How many of you have done it with complex conjugate? Nobody. Yeah, well, it's terrible because I didn't tell you the quick way of doing it. All right. John, who else has done it? Okay. John, Adam gets, who else has done it? Submit it. You have to submit it.
My computer's not working right now.
So, who else has done it?
No, that's not fair. How could you give him? You haven't even
No,
done
because
it.
you spend all the time doing it and the rest of you haven't done it.
Well,
With
give us-
good reason.
did find a mistake earlier on, so I did.
Yeah, still I will give you bonus for this.
Well, give us a few. What if I
Adam gets a 2-point bonus for this homework, and obviously part I is postponed until after we have done the computer part of exercise 2.
What if I do it?
You want to do it, the easiest way of doing it is the way we're going to do exercise 2. I forgot we didn't finish exercise 2. The easiest way to do it is very easy to do it like we did exercise 2.
I also went ahead and did that one.
I know this, I know the deal when we did that together.
I had a real rough weekend.
Sorry, Anna. Anyway, you get 2 bonus. You do get 2 bonus points
That works.
for the homework.
That works.
So homework, problem I is postponed till after the exam, after we have done. It's not so bad to do.
It's not so bad.
No, once we have done exercise 2, it's just like exercise 2. It's an easier version of exercise 2. But now actually I'm going to change it. Because I will modify I to make it for GF, not for GFC. Anyways, you haven't done it? I will change it to be for GF so you can compare with this and see all the nice features.
So, this homework should stop after H.
Yeah, stops after H. So you only have to do H. I did with you. G. I did for you F and G. You still have to do H.
So, let's do before the exam.
Class exercise 1 still due, but not the second problem?
Right. Yeah, in class exercise 1, I made that clear in the email. Obviously not exercise 2. All right, so we will stop at this point. So definitely need to have done the homework before the exam. If you look at all the exam problems, of course I will talk to you tomorrow, but since I have it up here, if you quickly, let's go quickly to the class website. We go to the class website and look at some exams. Like, oh, you have to be careful. Previous exams I have given you. So, in the regular class, spring semester, I have more time, more weeks. So there are 3 exams. Here in the mega course, which is only summer, I have 2. If you look at exams 1 of 13 and 14, everything is fair play. We have covered, obviously, everything here. But you can see, for example, this problem. Okay? Would they say, if yes, what is the new steady state? This is a problem exactly like what we discussed today, problem number 4. If you go to, that was 13, if you go 14, you'll see another problem like that.
Yeah, that number 4 is really hard.
Well, you can ask me to do it tomorrow. Okay? If you go to exams of the megaphone, so exam 1, spring, let's spring. Define megaphone.
It's down.
Should I put some megaphone? Yeah.
The graphing one.
Now, the graph I haven't yet covered.
Okay.
Problem 1 I haven't yet covered.
Oh my gosh, I was looking at it like it.
So that's what I want to do is see a computer example. I'm pretty sure I put some computer examples.
Some of those also have second order differential equations with different constants. That's something that's failed.
Why can't I get back?